Okay, let's take a look at the Pythagorean theorem. All right, so the Pythagorean theorem is used to find the missing side of a right triangle. Sides A and B are called the legs, and they are the shorter sides. So we can see in this figure up here, the legs are A and B. They are the shorter sides. C is called the hypotenuse. Hypotenuse. And that is the longest side, and it is also the side opposite the right angle. So if we take a look at the figure up here, our hypotenuse is here. We can see that it is opposite that right angle. So it doesn't matter how the triangle is flipped, you can always locate the hypotenuse by looking at the line opposite the right angle, or the side opposite the right angle. And we use the formula a squared plus b squared equals c squared to find the side length of any missing side on a right triangle. So the Pythagorean theorem must be used with a right triangle. Okay, so let's take a look at this first example here. We want to find x. And this is the hypotenuse, and I know that because it is opposite the right angle. So I'm just going to simply plug in my given values here, 8 and 13, and solve for x. So I'm going to label this A and B and simply plug it into this formula here. So 8 squared plus 13 squared equals, we could either say c squared or x squared. It does not matter. I'm going to put x squared, but you can put c squared. It doesn't matter what variable you use. All right. And also you could flip the 8 and 13. So you can flip A and B because they are legs. So it doesn't matter if you plug it in for A or B. You're going to get the same answer. All right, so let's just simplify. That is 64 plus 13 squared is 169 equals x squared. 64 plus 169 is 233 equals x squared. Now we have to get this x by itself. So remember, the inverse of x squared or something squared, to get rid of it is to take the square root. Gets rid of this 2 here. We're left with x equals the square root of 233, and that is 15.3. So in your calculator, you would just leave it as 15. Put it in, and then you would get 15.3. All right, so that is my answer for number 1. All right, so let's take a look at this example here. A little different. We see that 9 is our hypotenuse, and again, I know that because it is opposite the right angle. So I'm going to be solving for one of my legs. All right, so I'm going to set it up so I can label this as C. The 7 could be A or B. I'm just going to label it A and just plug it into this formula here. So 7 squared plus, I could either put B squared or X squared. I'm going to put X squared, and then C is 9, and simplify it. 7 squared is 49 plus X squared equals 9 squared, which is 81. And we subtract 49 x squared equals 32. And I could take the square root. Square root of 32 is 5.7. And if I wanted to write it in simplest radical form, remember you find 2 factors of this number, so 2 factors of 32, and one has to be a perfect square. So factors of 32 are 16 and 2. The 16 is a perfect square, so I could take the square root of 16, that would be 4, and leave my imperfect square under the radical. So I've written my answer as in simplest radical form and a decimal. So for example 3 here, I would like for you to try this problem on your own. It says dog agility courses often contain a seesaw obstacle as shown below. To the nearest inch, how far above the ground are the dog's paws when the seesaw is parallel to the ground? So you're given an image here, and you have this triangle right here, and you just want to find the missing side length. So go ahead and pause the video and try this problem on your own. All right, so you should have gotten B equals approximately 24.899792. All right, and you could round that to 25, the nearest inch. So I hope you got the problem correct. All right, so let's try this example here. Looks a little different. You don't exactly see a right triangle, but we can make one. If we draw a line from here to here, I'm trying to draw it straight. That's a straight line, and it would be perpendicular to the other side here, or the side with length 18. So that will make this a right angle, right? And so that will make this figure here a rectangle. So these two would be the same length right here, okay? So if we just find the length right here from here to here, all right, it would be the same length as the x we're looking for, all right? So we have our hypotenuse, and we know that this is our hypotenuse because it is opposite that right angle, all right? But we can't use the entire length of 18 because we're only using this triangle here, okay? So what would be the length of just this side from here to here? Hope you can see me drawing in. So if this is 5, then the length here would also be 5. So if that entire side is 13, then from here to here, it would be 13 as well. All right, so my hypotenuse is 16. One of my legs, I'm just going to call it B, would be 13. All right, so I'm just using this right triangle here. So I'm going to plug in 13 and 16 to solve for x, which is one of my legs. And if I do that, I will find the value of this x. All right, so let's just plug it in. I'm going to say x squared plus, so my b is 13 and c is 16 squared. X squared plus, so that's 169 equals 16 squared, which is 259. Subtract 169 from both sides. I'm left with x squared equals 87. Then I take the square root. Square root of 87 is 9. Alright, so I found the value of x here. That is 9.3. Okay, so for example 5, I would like for you to try this one on your own. A little more work involved. We want to find the value of x, but I've given you a hint here saying that you could use the Pythagorean Theorem more than once. So go ahead and pause the video and try this problem on your own. Alright, so you should have gotten 33.6 for your answer. Hopefully you got it correct. If you did, just fast forward the video a little bit. If not, keep watching while I'll explain it. So you could label this piece A and this piece B because you have two separate triangles here. And so for the first one, a leg would be 12 and my hypotenuse would be 14. So when I plug it in, I get 7.2. All right, for that second triangle there, I have a leg of 12 as well. My hypotenuse is 29, and again, because they are opposite the right angle, and we get 26.4. So we just add those two numbers together to get 33.6 for the entire length of this side here. So this was 7.2, and this was 26.4. Okay, so let's take a look at some word problems here. For this one, it says a roofer leaned a 16-foot ladder against a house. If the base of the ladder is 5 feet from the house, how high up the house does the ladder reach? So it helps to draw a picture. So if this is my house, makeshift house here, and this is my ladder. So the ladder is going to be slanted, right? And that ladder is 16 inches, or 16 feet rather. And the base of the ladder, which is here, so this is the base of my ladder, is 5 feet from the house. So this is my house. So the base is 5 feet from the house, which will make this length here 5. How high up the house does the ladder reach? And so we want to find the height, how high up this ladder is, so that would be x. All right, so this would be a right angle here, because the house, you're going to have a straight wall, so it would be perpendicular to the ground, so that would make this a right angle. So that 16 would be my hypotenuse, and I just plug it into the Pythagorean theorem. So that's C, and I'm going to say that this is B. All right, so x squared plus 5 squared equals 16 squared. That is going to be 25 equals, 16 squared. It is 256. Subtract 25. X squared equals 231. Taking the square root. And x is 15.2. So that ladder is 15.2 feet high on the house. Alright, so I'm going to do this word problem, and the next one I'm going to have you try on your own. It says Kurt is building a rectangular deck, so let's just go ahead and draw a rectangle. Get a picture here. If the dimensions of the deck are 10 feet by 23 feet, so the length is 23, shortest side is 10. What is the length of the diagonal of the deck? So that would be from here to here, diagonal. All right, this is also 23. So it doesn't matter what triangle I use. So this is a right angle, this is also a right angle, because remember, in a rectangle, all of the corners are right angle. So my diagonal would be C, because that would be my hypotenuse, which is opposite my right angle, and I just plug it in. 10 squared plus 23 squared, I'm looking for C. That would be 100, and again, it doesn't matter what variable I use. 529 equals C squared. Combining my terms here. And square root. So that would be 25.1. So the length of the diagonal here would be 25.1. Alright, so for this problem, I want you to try it on your own. It says a 31-foot support wire is attached from the top of a 25-foot telephone pole to a point on the ground. How far from the base of the pole does the wire meet the ground? So I would like for you to pause the video and try this problem on your own. Alright, so you should have gotten 18.3 for your answer. I've drawn a little picture here. I have a little picture here. And so the hypotenuse was 31 because it's a wire attached to from the top of a telephone pole. We could say this would be our telephone pole to a point on the ground. So that would make it diagonal. How far from the base of the pole does the wire meet? So that would be one of my legs. And the telephone pole is the 25 feet. So you would be finding one of the legs. So you should have gotten 18.3. Alright, so we're going to take a look at the converse of the Pythagorean theorem. That states that if the sum of the squares of the lengths of two sides of the triangle is equal to the square of the length of the third side, then that triangle is a right triangle. So basically, if you take your two shorter sides, which are your legs, A and B, and plug it into the Pythagorean theorem, if it is equal to the square or that third side squared, which is your longest side, then it is a right triangle. But if it is not, so if A squared plus B squared does not equal C squared, then it is not a right triangle. All right, so I'm going to complete one problem and you're going to try one on your own. Okay, so let's take a look at this example here. It says a triangle has side lengths 11, 19, and 28. Is this a right triangle? So those two shorter sides, 11 and 19, are my legs. Or they're the shorter sides, rather. So they're going to be A and B. And then C is going to be your longest side. Alright, so let's just plug it in. 11 squared plus 19 squared is equal to 28 squared. 11 squared is 121. 19 squared is 361. 28 squared is equal to 784. You can kind of already see that we know that 121 plus 361 is not going to equal 784. Let's just add them anyway. It's actually 482. Alright, so this is not a true statement, so this is not a right triangle. Okay, so for this example, I'd like for you to try this problem on your own. It says triangle has side lengths 85, 84, and 13. Is the triangle a right triangle? And explain. So go ahead and pause the video and try this problem on your own. Alright, so you should have gotten, yes, this is a right triangle because you get 7,225 on both sides. That makes a true statement. And so a triangle with these side lengths, 85, 84, and 13, are a right triangle. Of course, they were not in order, but make sure you always put the shorter sides for A and B. So hopefully you got the problem correct. Okay, so we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are special right triangles and similarity in right triangles. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me. And subscribe. And once again, I want to thank you for learning with me.